All right, so we'll try to keep this as short and brief as possible. If you had looked up at that assignment board or whatever it is you want to call it, I had that first paper due on Thursday. I pushed that back to the 4th or Friday, and I sent that out to you three sitting out there in the gallery. Okay. Because there's some extra material on there that does pertain to what it is we're doing. Okay, but I don't want it to be a total surprise either. Okay, so when we're drawing these structures, I think, are we getting, not that we would know, but are we getting better at drawing isomers then? Do you think? And maybe you don't know. Depends on the day, maybe. Okay, well, we'll say today is good. Okay, and the reason we say this is if we're drawing propanol, okay, there's only one isomer that exists for that, and that would be if you just move that OH group one to the left or one to the right, because if you put it back on the other end, you've got the same compound. That's what we were discussing yesterday when we had mentioned that of ethanol. Even if you're moving the OH, it's still going to be the same compound because, of course, ethanol would only have 2 carbons. And we had said probably the most important part of this is what we're going to be looking at here next. I don't think we got a whole lot left. Okay. Yeah. Okay. So as we look at this, okay, primary alcohol, okay, that would mean if that is attached at the end. That's what it means by one other carbon. That means that OH would be on the, like ethanol, propanol, butanol. And if you wanted to say one propanol, one butanol, one pentanol, that's fine, but it's not necessary. It's just understood that it's on the first carbon, and that is only attached to one other carbon. And of course, when we look at this, a secondary alcohol, okay, that means that carbon that contains that OH group is attached to 2 other carbons. And I think it's one of those aspects, if you put X marks the spot on there, I think that's hopefully very beneficial, at least until you obtain a really good understanding of this. And we really can't judge how well we understand this. That's something only you can answer. And just like perhaps it was with last year, if you're struggling with this material, remember you've got other classmates and teammates to help pick you up. Okay. So as we had just briefly put a little bit of time on what a tertiary alcohol is, and as we look at this, okay. Okay. So I want to make sure, of course, we get through this one. And this is probably, once we get down to here, we'll probably stop for today, at least with this part. Well, yeah, we'll just go ahead and go to the end here because we'll be talking about this a little bit, some of the reactivity with what we see here. Maybe these morning practices are all right. We're already but you can go home after school, or is it 2-a-days? It gives you something to look forward to then. Yeah, we'll go with that. Okay. Hey, I think Kansas plays tonight on ESPN, so Kentucky, yes. I think that's an annual event that Michigan State plays Duke, and then I don't know if Kansas goes to Kentucky or vice versa. So just happened to pop in my head when I saw that Jayhawk on there on your shirt. So what's his name anyway? How can you not know what the name of that? How can you wear the shirt if you don't know the mascot?
Because my dad used to buy us stuff because he likes the team. So,
Well, usually that transfers over to
no, I don't really
whoever
watch
purchases it. Oh. Okay. Fair enough. All right. So as we continue to move forward then, okay, just got a few things I want to go over on the board. And one of the things we'll see how much of this material you actually remember. And perhaps hopefully, you'll set yourself up for maybe somewhat of a surprise. We'll see. All right. And this is how we started today. What do you suppose, if you have a really, really good understanding of this, you would be able to answer that without drawing it? Do these two things have anything in common? True. Yeah, that's exactly right. Yeah, they're both propanol. Are they have anything in common with one another? True. That's true too. They're both alcohols. Yeah. Starts with the letter I. Yes, they're isomers of one another. That's right. Okay. So if we had to draw these out, okay, what are we going to start with? You're right. Why are you right? Okay, right. Okay, so if we do this, you correctly said 3. Okay, we got propane, but it doesn't say propane here. Okay, and again, number 1 is over there or over here. I think it's just human nature to read left to right, and I'm willing to bet that a lot of you would just do that, and I would probably be the same. Unless you're maybe left-handed, I guess, I don't know. Then maybe you'd put it on the other side. And you can even put it on the bottom or the top, okay? Doesn't make any difference, okay? That is going to be, if you really wanted to be specific, you could say 1 propanol. With one of the last things we talked about up on the overhead, what else do you know about this compound? That's probably more important than knowing the name of what this is. It's one of 3 things. We said probably the most important part about this is knowing what? Okay, what? No. Yes, right. Knowing where this is at. And putting that X on there, does that help you? And maybe it does on your end, okay? If it does, keep doing that. So we know that this is an alcohol because it says it here in the name, okay? So there's our OH group. If it helps, say X marks the spot here, and that is attached to one other carbon, therefore making this a primary alcohol. That's probably one of the most important aspects of knowing what this is, okay? Other than just calling it propanol. Okay, how is this compound different than this one? Right, we got that OH then in the middle. So top or bottom? I would have said top, that's okay. Now, how is this one different than this one now? Yes, so if we say X marks the spot here, this carbon is attached to two others, therefore making this a secondary alcohol. Okay? And then in this case, what is this one? I suppose I could have did just, yeah, we're good at drawing six-sided figures anyway. Okay, so we know that hex means 6. Boy, that's pretty bad. Okay. All right, that's not much better, but you get the idea. We have all single bonds in here, and then somewhere there is a what? There is an alcohol or OH group. That's probably the most common place to put that. And finally, is that a primary, secondary, or tertiary alcohol? So that carbon is attached to how many others? Well, we're going to have 50-50 chance. It is 2. Yeah, that is a secondary alcohol. Okay, so if we kind of had like a magnifier here, okay, so if we have that on there, okay, and we say X marks the spot here, this carbon is attached to 2 more. This one and that one. Therefore, making that a secondary alcohol. Okay, I would agree ring structures are probably a little more tricky, difficult to deal with maybe, however you want to look at that. Until you get a good understanding, putting these X's on there probably would help. Okay, we can go ahead and erase this. So now what we want to show you holy cow, we're just gaining numbers by the moment. We just can't get enough of this stuff.
Where is everyone at? They're an egg? Okay, I'll get them up later. All right, girls, I'm guessing that you're just momentarily waiting to put your masks on. Okay? I've got about 4 things. All right? And it's going to make things run a lot smoother around here because I will be happier. Okay? First thing, yesterday I found 3 different candy wrappers in the hallway. All within like 3 feet of a garbage. Okay? It literally ticks me off when people just throw stuff wherever. Okay? So, if I find any more wrappers, we're done with food during the school day. Okay? So, one way to help that is if there is a slob around and you notice them, maybe you could mention it to them or make sure that they get their crap in the garbage. Okay? I also had 2 disposable masks thrown within a foot of a garbage can yesterday. Not in here, but like anybody's parents just pick up for them at home. You just get to throw your stuff wherever. And I don't know who it is, but I'm going to talk to everyone. Thirdly, I kind of found out later after the fact that someone was maybe getting breakfast for you guys because you're going to be late today. That's a different story a little bit. I do not want people eating breakfast outside of the lunchroom. Okay? I have food that gets left places, and then I have other problems. Okay? Makes sense? Fourthly, a couple spokespeople from your class came in yesterday, and we will, before the end of this semester, start senior privs and an open campus period. Okay? There will be some responsibility with that, but okay? But we will start it. So when we have finals those 2 days, you probably won't have to be here all day either, okay? If you don't have tests, I just got to figure that out. And lastly, I think we've talked about this before, but during lunch period, I do not want people out wandering the last 10 minutes of lunch, okay? If you're going somewhere to visit, just visit in the lunchroom, okay? If that happens, you will get your 2 hours of open campus, senior privileges, whatever, okay? But if I have people coming to me saying, I don't know where this person is, then it takes more time for me. Does that sound fair? Yes? Okay, all right. Take care of it and everything will be fine. Sorry, Mr. McKinney. That's all.
Not a problem. Anytime. All right. So this is the correct structure for that. How is this different now? It is. So that means the structure is going to be different. You still have 3 carbons, but Al means something altogether different. Because OL means alcohol, Al means something totally different. Anybody? Okay, so if we wanted to change this compound to that, okay, something here has to be erased. I'm going to take that off, and that is hopefully enough of a clue. Say that again. Okay, you're right, but where? So if we took this off, that must mean it needs to gain something somewhere. So when you say double bond, there's our double bond. Now we're really close. How many bonds does that carbon have with the X on it? Oh, yeah. Yeah, I'm sorry. You're right. The one in the middle. Yeah, this one's got 5. You know, I had the right idea. I just did it on the wrong side. That's what I meant to do. That's true. I can see why that would be confusing. Now, how many bonds? 1, 2, 3, 4. Okay, so that carbon's fine, but what about that oxygen? Or not that oxygen, that hydrogen. Now we've got the right structure. This is no longer an alcohol, it's this, which is... From a long time ago, I get that. It's either an acid, a ketone, or an aldehyde. Dun, dun, dun. Yeah, okay, so we've got an aldehyde now. That's what we've just created, is an aldehyde. Okay? Now, and we've said this before too, you come in here and you take your fingernail polish off with acetone, right? But that's a common name. Acetone has a scientific name too. Okay? And it's really closely related to this. Because when we look at the suffix of acetone, it also ends in O-N-E. So therefore, what that means is if these are closely related, which they are, this has a double bond in oxygen where the X was. What do you suppose is going to happen to this one? If we put a double bond in oxygen on that X, what would we do with this one? Probably the same thing. Okay, so in this case, if that's gone, Now what do we have to do? Because how many bonds does this carbon have now? It's got 5. You can't do that. You're breaking the compound apart if you take them 2 off. So therefore, we're going to take him off. So now, there is no such thing as writing propanone like this. You have to account, just like when you had to say 2 where that OH group was, you still have to say where that double bond is. Therefore, you would change that to propanone. Okay? Are we lost?
Not too bad.
Not too bad. So we have one that says maybe, one that's not too bad.
It's alright.
It's all right. All right. So with this then, because I see tomorrow we're going to talk about some dehydration reactions. Can I erase this? Maybe I can see where kind of, we'll base this off of prior knowledge, kind of wrap this up because we kind of got interrupted there and we lost a few moments there. No big deal. We can make that up. And I still have to go over that tertiary alcohol at some point, but we're not going to do that right now. Okay. What was significant about Markovnikov's rule, going back to last chapter? Had something to do with major and minor. Maybe that's a ding, 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 ding. Oh, I get it. I remember now. We'll illustrate that. Okay? So we'll keep it the same. We'll say we got propene here. And there's no reason to write this down unless you want it to keep current with what we're doing. I guarantee you have this wrote or written somewhere in your notebook. Okay? So if we were to do this, ho, 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 yeah, we had more than that. Okay. Why do you suppose we want this in different colors? Because what do we notice about that reagent or water? Is it symmetrical or asymmetrical?
A.
It's asymmetrical. What's true about this alkene? Is it symmetrical or asymmetrical? It's asymmetrical, okay? So what we see happening then, does this need a catalyst, do you think? And again, we just continually ask this just to kind of refresh our memory before the end of the month gets here. The only double bonded compounds that needed a catalyst were the aromatics, those benzene rings. This is really, really unstable, so it breaks very easily. So what we see happening, these are all single bonds now. Why would we write 2 of these, do you think? Because there are 2 products, but you really had to be specific because the conditions are just right. We've got an asymmetrical compound, an asymmetrical reagent. Since this is asymmetrical, it splits apart right there. So we had to have major and a minor product. Now does that maybe somewhat ring a bell? You tell me, where do you want that OH? The second carbon, okay? So we'll go ahead and put them here. So that must mean that this had to gain one bond and this one had to gain one bond. So that's, we illustrated it there. So here's one bond, here's the other. So therefore, that's where that hydrogen is. So in the other product, we'll just flip-flop these, okay? We'll put the hydrogen here and the OH there, okay? Besides naming, how do you distinguish the difference between the two? We had said,
Hydrogens on the end, that's the major.
yes, that's correct. I had to think about that for just a moment. Yes. So this one, as you correctly said, is the major, and then this one is the minor, okay? This is something that you learned last chapter. You probably didn't know it was going to come full circle because we're only going to do half of what we're going to do, get a little bit ahead tomorrow because we're talking about dehydration reactions. So if you're staying hydrated, everyone's got what in their bottle? Water. So if you're adding water, that's hydration. If you are removing it, then what's happening? Dehydration. So what that means then is we can go ahead and pick this major product, okay? And that is 2-propanol. So what happens when things get dehydrated? What do you tend to lose? Yeah, you tend to lose water. Okay? So we need something that works as a dehydration reagent. Oops. So when you lose water, you're pulling that back out of there. So that means when this reacts, that gets stripped off of there, that gets stripped off of there. Back with what we started. This was a hydration reaction, but you can also come full circle and go backwards and then dehydrate it to this here. So why do you suppose there's boxes around these? What do you notice from this side to that side? Yep. Are these present anymore? No, they're gone. They're dehydrated. This reagent then causes that to get stripped back out of there. So that's going to be one of the tasks that you will be able to do is we give you a reagent, and with your flow chart, you change it 3 different times and you go back to a full circle. That doesn't mean anything to you right now, nor should it, okay? And one of the things I want you to be ready for, whether it's a math class, an English class, whatever in college, okay, or technical school, okay? Sometimes you're going to have to face some of these challenges. Does this look difficult? Yes, it probably does. But again, it's the first time that you've seen it. Okay, I've got this paper here, and we will catch up to you tomorrow. Remember, it's not due on Thursday, it's due on Friday. We'll see you then.